Welcome back for another Flight Technical Services quick topic video. This month we're going to look at a question we get quite often. Why doesn't my magnetic course match the charted course? And the answer, of course, is molten lava. Well, sort of. The geographic North Pole is the Earth's axis of rotation. The magnetic North Pole is created by molten metal flowing around the Earth's solid metal core like a generator, thus creating a magnetic field. Unfortunately, the Earth's magnetic North Pole doesn't line up with the Earth's geographic North Pole. The difference is called magnetic variation, magvar, or magnetic declination. If that isn't confusing enough, add in the fact that the North Magnetic Pole is always moving in different directions and speeds. For aviation, NOAA publishes magnetic variation updates every 5 years, called epoch years. Because of the constantly changing and erratic nature of the North Magnetic Pole, 5 years was considered the maximum time between updates for reasonable accuracy. It's 2020, which also happens to be an epoch year, so you'll see that many of the airport diagrams have been updated with the most recent magvar data. Here we see the Kirksville Regional Airport, which is using the January 2020 data. Kirksville is on the agonic line with a magnetic variation of 0 degrees and an annual rate of change of 0.1 degrees west. Switching to the Fort Lauderdale Executive Airport, the magnetic variation is 6.9 degrees west. I learned to fly at Fort Lauderdale Executive many years ago, and the runways were 826 and 1331. You can see that today the runways are 927 and 1331 because of the change in magnetic variation. Let's plan a simple flight from Fort Lauderdale Executive to Orlando via the Pahokee VOR, PHK, and the Orlando VOR, ORL, along Victor 267. We'll be departing the Pahokee VOR on the 342-degree radial and coming into the Orlando VOR on the 162-degree radial. These are reciprocal radials, 180 degrees apart. This is common on north-south headings that parallel the isogonic lines. All these airports and VORs lie between the 6 degrees west and the 7 degree west isogonic lines. We saw earlier that Fort Lauderdale Executive was at 6.9 degrees west. To change the runway markings at Fort Lauderdale Executive from 826 to 927 required a little paint and updates to the airport diagram and approach plates. There's a lot more work involved in realigning VOR stations. They must be shut down, physically aligned, flight tested, and updates to every arrival, departure, and approach for that airport and every other facility they serve. So as you can imagine, they don't get updated as often. Let's look at our two VORs, Pahokee and Orlando. According to the airport facility directory, the magnetic declination for both of these is 0 degrees. Yet we know the actual variation is somewhere between 6 and 7 degrees. And we also know that the magnetic declination can't be 0 degrees in both Orlando, Florida and Kirksville, Missouri. In fact, the magnetic variation hasn't been 0 degrees in Florida since 1965 when the VORs were installed. So it's true, two wrongs do make a right. Since they're both wrong, but wrong together, it doesn't change the magnetic course on your GPS or FMS if the magvar value of 0 degrees is pulled from the database. Many pilots use apps today. Let's see what the same route looks like in an app. You can see we get 348 degrees magnetic, or the 168 degree radial, instead of the 162 degree radial, or about a 6 degree difference. Looking at the magnetic declination values the app is using, we see 7 degrees magnetic variation, which is more accurate, but different than what the FMS pulls from its database. Let's go back to Kirksville now and look at some nearby locations. Remember that Kirksville Regional and Kirksville VOR are on the agonic line. Braemar VOR, BQS, lies on top of the 1 degree east isogonic line, and there are 3 airports in between. The magnetic variation of M08 is 0 degrees, reasonable considering rounding. The magnetic variation of Kilo Charlie Hotel Tango is 1 degree east, also reasonable considering rounding. Trenton Municipal, Kilo Tango Romeo X-ray, a little further east is 0 degrees, which would indicate it hasn't been updated yet. Let's go from the Braemar VOR to Kirksville VOR and then join the arrival into Chicago O'Hare. You'll notice that Victor 502 leaves Braemar on the 60 degree radial and comes in on the Kirksville 237 degree radial. That's a difference of 3 degrees. Even though Braemar lies directly over the 1 degree east line, its magnetic declination is 3 east from when it was last updated in the year 2000. Kirksville, which overlies the agonic line, shows a magnetic declination of 6 east from when it was installed in 1965. So there's our 3-degree difference. Remember, north-south routes are less likely to have differences. East-west routes are more likely to have greater differences, especially for longer routes crossing multiple isogonic lines and to from VORs updated at different times. But even with those differences, we flew the same ground track. The variation just changed the magnetic heading value. Problems don't usually arise unless the amount or rate of change is large. Alaska is an example of this, where we need more frequent updating. Fairbanks VOR, FAI, has a magnetic declination of 21 east, updated in 2010. Sisters Island VOR, SSR, near Juneau, has a magnetic declination of 20 east, updated in 2015, and the Dead Horse VOR, Sierra Charlie Charlie, has a magnetic declination of 17 east, updated in 2020. Note that these are all epoch years, 2010, 2015, and 2020, and the rate of change is about 3 times greater than the continental U.S. We're finally on our way to join the arrival into Chicago. We're assigned the Benke 6 RNAV arrival, Kirksville transition. The first leg is from Kirksville VOR to Lomi intersection on a 68-degree heading. We see there's also the Bradford 7 arrival, Kirksville transition. The first leg is also from Kirksville VOR to Lomi intersection, but on a 59-degree heading, or a 9-degree difference from the RNAV arrival. So our original question was, why doesn't my magnetic course match the charted course? But the charted courses don't even match each other. Procedure design is beyond the scope of this quick topic video, but the aim gives us some insight. For the Benke 6 RNAV procedure, the airport variation is applied to the whole procedure. But for the Bradford 7 arrival, the VOR variation is used. The airport is 3.8 degrees west, while the VOR is 6 degrees east, which is roughly our 9-degree difference. Advisory Circular 90-105A, Approval Guidance for RMP, also addresses this. It says that the flight crew may notice a slight difference between the navigation information portrayed on the chart and their primary navigation display. Differences of 3 degrees or less may result from equipment manufacturer's application of magnetic variation and are operationally acceptable. Load this up in your favorite app and you'll end up with different numbers. This is becoming common with more and more RNAV procedures being added. Check out the Bruiser 1 and Eagle 6 arrivals into Phoenix Sky Harbor on the Zuni and Dojo leg. One of the last sources of variation we want to mention is probably the least logical to you, electronic data. You would think with electronic databases that you would be able to accept changes later in the nav database cycle, but it's actually the opposite. In the days when you spent your evenings in hotel rooms replacing charts in your jet binders, you had the latest data as soon as you received it. With electronic databases, the cutoff date is actually earlier because you need to track down the aircraft and physically load the database. When we used the magnetic compass as the primary or sole means of navigation, life was pretty simple. Plot a true heading, correct for the magnetic variation, and follow the bouncing compass. East is least, west is best. When radio-based nav aids were added, the concept didn't change much. Stations were aligned with magnetic north to match the compass. With the introduction of more sophisticated navigation systems and procedures, that all changed. Modern systems work differently. Each path has a beginning and end point defined by latitude and longitude. The system calculates the great circle true path between these points and applies a magnetic correction from a database or magnetic models based on the type of procedure. But at the end of the day, when we go to land, it doesn't matter if the runways are marked 826 or 927. The airport and runways haven't moved. Only the magnetic variation has changed. The runway markings are there for our alignment during takeoff and landing, and we get to the destination regardless of what our magnetic heading shows. Thanks for watching.